Yeah, so good afternoon, everybody. Maybe we didn't check that, like how many of you have earlier built systems with AI or agents? Maybe can we just do a quick poll? And, Raki, can you check that if you don't mind?
Yes, I had kept it ready. I've just launched the poll. I hope you all can see it. Please confirm if you can or cannot.
Yeah, I just wanted to get a sense of it so that I can speak accordingly.
Yes.
Yeah, so I think we get a sense that if you have actually worked on agentic or have some familiarity with it, and but most people don't have, right? So I'll kind of speak around that, and you can obviously keep your questions and use the chat interface to ask that, and I'll be responding to them later, right? So uh, just to help you understand, so I actually work in a startup as a co-founder with a UK based startup, right, called Simpli Automation. And what we do is basically we build AI applications, right? Mostly agentic. And this is mainly for the B2B kind of business. So in UK, for example, there are very large broker networks, right? And that sell like in millions, billions of pounds, right? They're very large. I mean, there are about seven, eight of them. And that is our main customer group that we try to sell to. And mainly our products are catering towards workflow automation, enterprise search, and basically we are building about 10 or 12 applications, and we have some customers currently, and we recently got funded as well. So that's the current status, right? I'll just move on. We'll just take this presentation journey from some basic concepts to getting to the more advanced learning, right? So yeah. So I thought, maybe it is good to first just set the stage for all of you, right? So that we get an understanding of the strengths and the challenges, right, with LLMs. And all of you, I'm sure, use LLMs in your daily life, including tools like ChatGPT, which is very popular, and many other tools that are, commonly used by, almost everybody for various purposes, right? So just to summarize the strengths, I would say the biggest strength of LLM over other AI models that are out there, I mean, non-language models, I mean, right, is basically the capability to understand languages or language syntax, word, grammar, extremely well, and often better than humans, I would say. Most people, I would say, right? So that is the reason, when you write the questions to like ChatGPT or any LLM, any large language models, even if you type in the question slightly wrong, right, it still can interpret the sentence fairly well, right? Unlike a human, right? If you just ask a question where, the sentence is poorly constructed, it might actually lead to a wrong answer by human, right? In many cases. But here you can see that, they have the language models are very, very versed in understanding languages, right? That they are trained on. And mostly English. I mean, obviously, because most models are trained on English kind of data and syntax. So that is the core strength if you look at, right? Other than that, obviously, the other things are the language models, right? So they have embedded knowledge right inside the data that is used for training uh, the language models, right? So what happens is that it actually responds extremely well with prompts. So depending on the kind of prompts you create, language model will respond very well, and it is actually tuned around that, right? So that's where the topic of prompt engineering comes in, right? That people learn how to write good prompts, etc. Right? Um, and obviously, it is very flexible for different types of tasks, right? So unlike a traditional application, right, that you might build, right, where you might actually use it for a specific use case. here a language model can be used for different use cases because you're mostly interacting using APIs, and depending on the prompts and the and the context you pass onto it. The context is nothing but it's like you're providing certain additional information. Could be some extract from a document or your chat history. Those actually act like a context for a LLM, and then it gets compounded with your prompts, and it actually spits out the final answer, right? And so other thing is also nowadays, if you look at the latest models which are available, like Claude and GPT, etc., they all actually are multimodal, right? So what it means is that it supports all kinds of data, right? Unstructured data. So like text or images, audio, etc., right? So you can actually blend different types of content together to enhance the final outcome that you want to create, right? And which can be very useful, right? If you think about it, right? Especially for all kinds of audience, right? So for example, some people may not be able to read very well, right? So you can actually use other forms of um, transmission of data, right? Audio and video, which is actually understandable, for example. So it makes it very versatile, I would say. And definitely the challenges are many, right? All of you must have known about it. The core main problem is the hallucination or giving incorrect or fabricated answers, right? And you need to understand why it happens, right? So if you look at any standard application or traditional applications, so to say, um, what happens is that they are being programmed based on certain rules or logic, I would say, right? So it's a logic driven, rule driven programming, right? So where you can actually define things if and else, and you can create certain, predefined, code structures, which based on the, even if you give the input, it will actually spit out an output. It also expects, the traditional programs expects that the input is of a certain structure and format, right? So that it can process the data, right? But that's not the case with LLMs, right? So you might be able to give different types of inputs to the same LLM. It can interpret that, right? But the main difference is that the LLMs in general are non-deterministic, right? So they are more predictive or probabilistic by nature. So what happens is that you can just by using LLMs, you may not always be sure that you are getting the correct answer or the answer which is the ground truth. I would say the facts. And that is where when you use any of this the language models directly, like a chat GPT or similar, you may not always get the right answer, and also it might be outdated, right? For example, depending on when the cutoff date was or the training data, right, it might be quite off. So that's another challenge as well. And in general, it is quite poor in mathematical work or computational work, right? That you might want to do, right? For example, you want to have it solve a math problem. You cannot really do that, right? Because it's the language model, right? So it has been trained on languages. As a result, it is often not well trusted by users. So let me now cover about more around the agentic application, right? So we first slide we talked about the LLMs in general. Now we talk about the agents and the agentic application, right? So we talked about the challenges there, right? So one of the things that agentic application does is actually solves those challenges with a given solution, right? That how to do it such that it sort of behaves fully deterministic, and you get answers. You have full control over it. It also can be autonomous and acts like a decision making system. Let's just like humans or a team of people, right? Like in your company you work, there's a team that you work with, right? And there's a structure of the team. There could be architects, developers, etc., right? And when there's a problem or whatever work you are doing, there's a discussion that you do and you make a decision, right? Where based on facts and figures. So agentic system can work like that, right? You can design it such that it actually consults each other. It makes decision. You can also use different agents to collect to analyze different areas, right, of a particular problem, and so that it can be well verified that the answer you're getting is correct. And it also solves some of the other issues, like you can look at your data security, for example. You can evaluate it, how well the answer is. You can score it, right? And then there are different, of course, agentic, design patterns which are there, which you can use like a multi-agent. You can have supervisor-based, and also some of the other areas of language model where you may not have guardrails or content moderation, which is often a problem, right? So which you can implement very easily in agentic system. You can also have human feedback, right? So you can have human feedback, which can be sent back as a feedback loop, and so that the next time the agentic system can have better, answers, right? So that is a very big advantage, I would say. And between the different agents, you can have voting and negotiation, for example, or you can ensemble the final output before you give the final result back. And the core idea is to break a large work into smaller tasks, right? Which kind of works, right? So if you think about uh, a real workflow, right? The workflow in a typical business, where there are maybe 10 different steps that a human does, right? Before something is, finally created, right? So it could be a sales process, it could be the way insurance is sold, right? In our case, the brokers actually sell insurance. They get, the customer requirements of the KYC of a customer, then try to search across different insurance policies to find the best match, right? And get the quotations, and they do the many things, and finally they probably create a readable output, right? Which could be a PDF or a presentation, which is sent back to the customer, for example, right? So this is like a workflow, right? Now you could actually automate this entire workflow, right, including agentic system, which supports tools and other things, which helps you do this very quite effective. And that's where I think the agentic systems are getting more and more you know adopted. uh, so let's now look into some use cases, yeah, for agentic system, right? And you must be familiar with many of them, and I'm sure many of you use many of these tools which are available, like Cursor and Windsurf and uh, co-pilots, and content generation tools, etc., right? Now many of the tools play very well in the B2C space, right? But at the same time, right, there are use cases in the B2B as well. A good example could be a CRM, right, where you can have agentic systems, right? Or even an enterprise, which is a large enough. We used to have this wikis, right? I mean, where you have your documents, and you want to search through something, right, quickly. Now, it often doesn't give you the answer very easily, right? Because you get many results if you search on a wiki or Confluence or similar tools. Whereas if it was driven by more of a agentic knowledge agent, right? So then what is possible is that you would actually get a concise answer based on the content, right? Or the context which is given, which is the content on the search. So obviously there is a lot of steps that goes into building a agentic system. We'll try to discover some of it today, right? And these are some of the use cases I've written here, and you must have heard about it. My recommendation system is quite popular. In our case, we use document review, we use workflow automation, and we're also using enterprise knowledge management, right? In fact, one of our customers is using the enterprise knowledge management product that we have built. Um, and in the generation type, there are many options, right? And you see a lot of applications that you see in the market are primarily in the generation category, right? Video generation, image generation, debugging your source code, or even design, so there's so much happening in this. Um, Now let's talk about what it takes to build an agentic application, right? So one of the areas is definitely like the way I would do it is I would first detail the use case, right, that you want to address to understand the main purpose behind it, right, and what the user really wants to, right, and especially in a B2B environment, right, it's also important to understand the customer's current environment because it's like even if you build a new application and you sell it to a customer, it's not like this application is going to work in isolation. It has to work with the other products and systems that enterprise has, right? Unlike a B2C where you can have an app which you can download and use it, it doesn't necessarily need to work with other apps you have, right? There's no such necessity. But in a B2B space, it becomes a necessity, right? So then you need to understand the integrations you need to build as well, and the source of data and other things, right? Um, and it's also good to understand that how does a human person does the given workflow right today? Right? What are the pain points? Where does he spend most of his time? So that you can discover the automation possibilities, right? Which part should you automate? And the other thing is also the once you narrow it down, right? The next thing is to understand the technology to use, right? What is available in the market now, right? And building a good understanding of it, I would say. I mean, you may not be an expert immediately, but building a good understanding of the choices that are available. Just like LLMs, there are so many of them available today, right? Which are comparable. Similarly, when you go to the agentic frameworks, there are so many agentic frameworks that are available, like LangChain, AutoGen, Vue is there, and IBM has one new one, right? So everybody is building, right, agentic frameworks, and so it's true with like vector databases and others, right? So it's just a lot of combinations to choose from. So it's good to do some evaluation, some benchmarking, I would say, understand your use case, your data, and what would work the best, right? What combination will work the best. And also, we need to factor the cost as well, right? I mean, from what I'm mainly presenting today, if you think about it, is more from a startup point of view, because we don't have that kind of capital like big companies, right? So definitely the design choices, architecture, which I will present today, is mainly around a startup, right? Which is which has just started with very less capital, but you want to succeed, right? So definitely, I also personally believe that design architecture uh, and cost, right, and quality, this all kind of goes together when you kind of build a product, right? Um, so one other thing is like ETL, right? ETL is a very common word or nomenclature used in the industry for data engineering, and mostly, most ETLs that you see in the market works very well with structured data, right? Which is your database data, or where the data has a structure or schema is associated with it. But when you deal with documents, videos, etc., the data is not really structured; it's unstructured data, right? So now you need to think of how to build a ETL pipeline, right, for unstructured data. So there's a diagram here on the right, which kind of shows a sketch of how a ETL pipeline for unstructured data might look like, right? So definitely, the key elements here is like you have tools nowadays like document parsers, which can extract metadata out of your documents, right? For example, you may want to extract the title, author, or maybe the version of the document, etc., right? Which is metadata. Uh, and then, of course, the content, right? And then you might transform the data, right? You may not actually want to use the entire input data because some might be repetition. You don't need it, right? So you might transform the data. There could be some pre-processing, and then you kind of what you do is a chunking of data, which is basically dividing the data into smaller parts, right? Because let's say your PDF file is let's say 30, 60 pages. That's the long one, right? So you probably chunk it into pages or half pages, right? Now, for chunking and embedding, right, there are different models which are available, which has the intelligence, right, to do what is called semantic embedding, right? So semantic, it basically looks at, it's not like just dividing the text into parts, but it looks into similarities, between paragraphs and tries to make a decision as to where I should break the page, right? And accordingly encode the data. So data encoding is nothing but converting a text into numbers, right? Because as you know, like any computer system stores numbers, right? I mean, it doesn't, I mean, it's good at numbers. You can do a lot of calculation with numbers, but difficult to do with text, right? So numbers is where the whole thing is, right? So if you have a sentence, it will be converted into embedding, which is a sort of, is a n by n matrix, you can say, or often called as tensors. So you basically get a array of numbers, right? Which has the representation of the text, right? So what happens is that this huge amount of mathematical data is stored, right, in a vector database, right, and which allows you to do a lot of searches, accurate searches later on, right? And so basically, it also works very similar, just like if you remember your high school mathematics, right, where we did vector multiplication, dot product, etc. There's basically finding distances between two vectors. It's like, two lines and you want to find distance between them. The closest distance between them are the most similar ones, right? And that is actually by different distance algorithms which are available, like cosine and different ones. And basically tries to find the closest distance, right? In nutshell, that is what it is, right? And then it stores the data in a vector databases. Now, vector database is also a very large field, and a lot of advancement has happened to that, right? And they're quite different from the relational database, right, in terms of how it stores the data, how it indexes it, and the different features it has, right? Uh, so one of the thing our agentic application is also to understand how to evaluate it, right? So evaluation is a very big area in that, right? Which I would like to emphasize because just like in normal software, right, you actually have a test framework that you use, right? So similarly in agentic frameworks also, there's a lot of evaluation ways of evaluating it, right? So that you can look at the tools you are using, right? Let's say you're using a weather tool or temperature, or you write different tools, right? And you can find the tool efficiency in terms of how well the agentic framework has been able to select the right tool, and how well it has, for example, been able to store and retrieve information from the memory, both short-term and long-term memory, or in the planning, how well it is good in strategic planning, right, for a task, and also how well it has basically, you know, has different components, and how well is the cross-component collaboration happening. So this kind of frameworks like Raga and all, they actually help you do that, right, very well. Um, and usually our development process is iterative, right? So you'd actually start and test it and go forward, right? So that's how we proceed. Here are some design consideration, right? I would not go through the entire slide just in the interest of time, but you can read through it. But essentially, one of the thing I must say, if you have built cloud applications before, cloud first application, uh, the concept is very similar in sense that ultimately you will be deploying on the cloud, and you have to structure your application in smaller parts like microservices, which are doing specific tasks, right? And you might use like a Kubernetes cluster, or so that you can actually have this kind of auto scaling and you know uh, redundancies, etc. Right, and you can have a full control over it. I typically like designing applications which are more cloud agnostic, so that uh, you are not tied to a single vendor, right, throughout your life. And changing vendors is not easy, as you might know, right? So it's a good idea to design from the beginning in a way that your cost is minimized, right? Your ongoing cost, and also you're not tied to a single vendor for no good reason, right? The cloud is a good example, right? I mean, there are hyperscalers, there are many vendors across the globe, right? Even in India, there are newer, cloud data centers available. So if you get tied to one of them and using cloud specific services there, it will be difficult to move later on, right? So that's something to I keep in mind. Um, and then, of course, safety and security and compliance becomes a big issue, especially when you're operating outside India and especially in the B2B kind of space, because there are compliance regulations now, GDPR, security like SOC 2, for example, and where you store your data, for example, and how you process your personal information of your customers, right? Like emails, phone numbers, etc. Right. So there are techniques such as anonymization, right, where you don't really send personal information over the wire to your LLMs, right? But you tokenize it or anonymize it, and once the response comes back, you do the reverse. Right. So yeah. So essentially, it's all about your planning of the agents correctly, and you know doing the observability part, right, in terms of how you're noticing the model usage, uh, the traces, like when the users are interacting, you need to track them, so that you might be able to make use of it to improve your performance of your agentic system. So there are tools available which kind of helps you do that automatically, right? It kind of tracks you. So we use one of them like that. So this is like a minimal deployment architecture, they call it, right? I mean, it's not like this is how it should be, but this is what I think is very valid for a startup kind of scenario, where what I have done is basically we are deployed on the Kubernetes cluster, self-managed, and it runs on a virtual network, right? The entire deployment, and then we have Quadrant as our vector database, which is which is very scalable and memory efficient. Um, you can run it on GPU also, right? You can use GPUs, uh, so which can speed up as well. So from a future point of view, right, it's good to plan out things which is more future. Uh, then we use Redis for just memory caching sessions, etc., and Postgres for other kinds of data like user data, etc. Right? Uh, you know, then we basically have open telemetry based collection of logs and events and traces, which are sent to, let's say, Prometheus, right, where you can actually have a real time tracing of your entire stack. And then we use LandFuse mainly for the LLM observability, like we showed in the previous screen, right, where you can look at your costs, your the kind of queries your uh, users are asking, their feedback. Also, you can track. You can also track things like um, whether the user is whether the LLM, your agentic system, is able to answer that question correctly, right? And besides, we also do the prompt management. That means, for different purposes, you would write different prompts, right? And you may have prompt versioning as well. And this is all supported in tools like LandFuse, right? So we basically on runtime we can change the prompt as well, and the agentic system will respond accordingly, right? Then we use feature flags, etc., right? Like launch dark, which is a feature flag where you can turn on, turn off features, right? Very useful for a startup kind of scenario where you want to test out things. And we have CI/CD with GitHub Actions, And what else? Yeah, and security is another area where you want to have like a real time, you know, monitoring and remediation. So there are lots of tools in that space. We are using one called Qscape, which is free, but there's a slightly paid version of that which has a nice user interface called Armo, right? So it basically runs as the Kubernetes operator, and you can actually look at your compliance scores also. It kind of shows you how good you are doing on SOC 2 or any of the compliance areas that you are tracking. So you're kind of ready on that. And the front end we have is a React based web application. It runs on mobile also, and and then we are using ingress controller, right, uh, for traffic, and we support TLS. So that's the basic about architecture that we're using. And so the last few slides are more around the core concept of getting high accuracy of results, right? So, for example, this customer we have, right? I mean, one of the complaints they had with the previous agent system they had used was that yes, it used to work, but it wasn't really accurate at all, right? So they'll not be happy about it, but they don't trust the system. So if your user is not trusting the system, and then it is not of much use, right? They're not going to renew the contract maybe. So accuracy is a very important subject here, and there are ways of achieving that. Uh, Especially, one big component is your vector database. If you're dealing with storing documents, etc., so how you store it and choosing the right vector database. Then other thing is the orchestration of your workflow, right? Where you can have frameworks like LangGraph I'm using, where you can define your agents and you can create different you know different workflows, right? That you can see on the right hand side, where you can, for example, you can search for a policy. If it is useful, you generate the results. If not useful, you transform the query, right? You change the query and give it another chance to the LLM, right? And once you get the result, you can also vet it with the web as well. You can involve a human in the loop to ask questions, and then finally generate the final result, right? So that's the whole idea. uh, Another area to look at is also like the prompt design, right, which is the important aspect. And another big area is also, I should mention, is the quality of parsers you're using, like PDF parsers or any kind of parsers, right? Now there are so many of them in the market, right? Many are paid, some are free, right? So we are using something called Llama Parts, which is on Facebook, and essentially, what is good about it is the fact that uh, if you have complex documents and images and maybe audios as well, it kind of works on all kinds of media. Number one. Number two is that you can also, unlike most of the parser that you see, the traditional parser, which are OCR driven and rule based often, right? This Lava parse, the difference is that it can actually take prompts, right? So you can actually, so behind that, there's a LLM, right? So you can actually give a prompt. While document parsing, it's going to use the prompt to parse the document and produce an output which is much more better than a standard parser that you would use, right? So what I mean is that when you look at the tool set that is available in the market, do a thorough study, do some experimentation, and then make a decision. Yeah, so just on the accuracy and speed, right? That's another thing. So when you deal with especially vector search and vector databases, usually there are three quadrants, like on the right side, bottom, the triangle. It kind of shows that you get higher precision, high speed, low memory. So you have to choose maybe two of them, right? That you really need. You can't have everything, right? So you have to choose two of them. So the reason is that the more the vector embedding, the length of the embedding, right? That actually that is one factor, one of the factors produces higher accuracy. But it actually has, the pitfall is that, yes, you have to store that many numbers, right? Or that many tensors, right? Which obviously in memory, it can have, there's a cost implication of that. Similarly, there are many other aspects to it, right? For example, if you look at the embedding types, right? There's so many different embedding types which are there. How are you doing the embedding? Uh, so, for example, there are dense embedding, there's sparse embedding. But depending on the type of data you are dealing with, right, you may choose, right? The sparse is actually good where there's a few occurrence of certain, uh, you know, certain topics, right, across the document, but not like all over the place, right? So, or you could actually club together. So, many of these vector databases support like multi-vector, or you can have a hybrid embedding, for example, dense and sparse. So every each of your embedding they will have multiple embedding for the same payload, right? And then you can have there are models like this Colbert, right? So Colbert is a BERT. The Google had the BERT algorithm, right? So Colbert is derived from there. And what it does is that what they call is late embedding, right? So late interaction embedding. So it basically allows you to sort of do a re-ranking of your results from the vector database before you get the final result, right? So it kind of works more efficiently and usually produces a better result. Especially, so you have to imagine that it's not like one or two documents you are dealing with. You may be dealing with thousands and thousands of documents, right? You take a large corporation, they have very large document set. And not just documents, there are YouTube videos, there are so many stuff, right? And the total, total volume of data you're dealing with is humongously large, right? So that is where the tuning of this and understanding the settings and parameters of a vector database, embedding, etc., plays a role. And then, of course, you can have GPU accelerated indexing, right? If you feel that you're not getting that kind of speed, right? And there's a lot of details around it, of course. And and if you look at the left hand side, it's more about the interaction in terms of the multi-agent system. So you can have a interaction flow between them in terms of how they are, uh, sort of interacting between each other. So I just wanted to summarize a few research findings. You might find it interesting. So when I was doing it, initially, I did this, some study on this. I did some research, finding the right tools. For example, what really matters, like prompt management, for example, really matters. If I'm using a vector database, choosing the right one with various features like distributed deployment, for example, right, which is a great place for Kubernetes. Uh, Supporting complex filters, right? So filter is a very important aspect of a quadrant, I would say. Not all have the similar capability. The filter is like, you are doing the similarity search based on your embedding, of course. Filter is a top up on that, right? It's similar to what you do in a database using where condition, right? Where you have filters. So quadrant supports both, right? So you can have filters, you can do a normal embedding based similarity searches or nearest neighbor. Plus, you can also do this as well, right? You can use filters and you can store different metadata. For example, I can store metadata like, like document type or insurance type, right? A health insurance or life insurance. So when I'm searching, I'm already reduced the set, right? So I'm likely to get my results very quickly. And then integrations, right? So, the popular frameworks like Spark or EMI, if you have integration with them, you will be able to use, like your ecosystem much, much better, right? And then support for various agentic frameworks. So for example, we are using LangChain and the LangGraph. So I would prefer to use a vector database that is compliant with that, right? Because that saves a lot of time. And we spoke about the embedding model, right, which helps in getting good accuracy. Document parsers are important. And so it's like tracking new innovation and experiments, right? So what is happening in the industry, a lot of countries are contributing. So it's good to understand that. And this is the last slide, which is more about the future trends. This is just my take on this. So definitely the future trend, if you look at, years, next year and the year after, we're likely to see more focus on safety, data security, compliance, observability, etc. And that's one area which is very mature in the traditional application space, right? And that's something which is coming up here, especially for large scale applications deployment. New protocols, I would say, right? You must have heard about NCP or A2A, right? Agent to agent communications. MCP is like a tool server, right? Where you can use tools like all these cursors and all. They do that, right? They use MCP. So also like various cost optimized model, because models are expensive to build, and context window is another challenge, right? So most of the newer models have context window about 2k or 200k, right, of tokens, right? However, if your context is large, right, it may not fit in there, right? You may have to do something about it. So that's where the newer direction will be on having larger context windows. I would say improving the explainability and variability of your results, and focus more on fine tuning specific models. Quantization I did not speak about, but the concept is when you're storing your embeddings, you typically store in float at double, right? But when you quantize a model, right, you have an option of storing almost similar information in a much lower data type, right, like integer or maybe binary, etc. Right, and that saves a lot of cost and size of your module, right, of your vectors you're storing. And obviously the retrieval goes much faster. Other areas expected is like FinOps, for example, which is quite prevalent in most of the cloud applications. And something around the agentic microservices frameworks, which you don't have anything specific now, but that's something which might happen. And then, of course, usage of more of the vision models, multi-model, right, which you're seeing, but I'm sure there will be more. So that kind of completes the presentation. We can open up for questions if I'm.
So, Atanu, we have received a couple of questions.
Sure. Why don't you? Yeah, if you can take it up.
Shall I read them out?
Yeah, or somebody can speak, whichever way you want. Yeah, whichever.
Okay, so I'll just read them out. The first one is by Prajwal. He says, I just wanted to ask that everyone says that cloud and AI are going to boom, but I don't see many companies taking freshers as cloud engineers, even for junior positions. What is the reason behind it? How a student can get into cloud? In what way should a student prepare to get an internship or a job in a cloud based company?
Yeah, no, this is a good question, although not directly related to the presentation. But what you're saying is correct. Is a correct observation, and that's true across the globe. And the reason is that what is happening is also that the requirement for uh, the requirements have changed. I would say, right. So there was a time where companies would hire lots of people, right, and there were more manual work, right. I would say the work which could not be done with software and tools, right. So naturally, the kind of work they would do, right, required more people. So that was one reason. And second is obviously the some of the tools that has come up has augmented, uh, some of the basic tasks, I would say, and also they're not bad, right? If you know how to use the AI driven co-pilots and other tools, right? I mean, they're quite useful. I mean, they're not very accurate often, but they're not bad either, right? So you should know how to use it. And that is what they call the vibe coder, right? The vibe coder, right? You hear that term a lot. And, so that's another factor as well. And then, of course, if you look at the growth in the market, so there are two kinds of people. If you look at, like, one who are innovators or creators, and who are building new technologies, new products, right? And then there are users, right, who are using those technologies, right? So if you belong to the innovator category, you obviously will have lots of opportunity, right? Because that's the cream of the society. And if you're asking me how to get into a cloud company or similar, definitely one of the main thing is to have hands-on experience and do some work or project yourself, right? Something that works well, and and you know try to learn. I think learning is the main thing, and be able to explain what you have done, right? So most of the time when I talk to interns, right, I face that difficulty that they might say they know, but they're unable to explain it. And the second factor I would say is, especially, hired one intern last year, last 3 months back. And one thing we found was, I think that he was a good student, but when it comes to work, he found it is bit sloppy, I must say, right? So, if I look at my younger days when I was 22, I mean, we would actually take any work very, very challenging. I mean, we would actually make sure it gets done, right? No matter what, right? Even if it is 10 at night, whatever, right? So that kind of hunger is required, right? So which I'll be honest, right? I don't find that so much with many of the young interns, right? Maybe that's something also is creating issue. Yeah. Let's take the next question.
Right. Thank you for answering that. So the next one is from Santosh. He has a couple of questions. Shall I read them out all together, like one by one?
Yeah. Yeah. Let's do one by one.
Okay. So the first question is, could you explain on augmenting LLM? How is it different from using SLMs?
So SLM basically is all about the. It's nothing. I mean, it's the same concept of a language model. A large language model, usually we are dealing with many billions of tokens during training, right? So we are dealing with very large amount of data, maybe trillions and trillions of data with billions of embeddings, right? So what happens is the knowledge or the information that is being embedded into the language model is massive in case of a large language model. In case of a smaller model, it is not so. So usually smaller models, and also there are features that a large language model will have, which a SLM will not have. Right? Let's take some example. So, for example, most of the large language model today support what they call function calling, right? Where you can call tools, external tools, or you can create structured output, right? So, structured output is nothing but when the final result is generated, you want to send it as a JSON or a markdown or similar, right? You can fine tune the output, using the LLM features, right? And there are many such features which is mainly built in the LLMs to so that someone can use it to build applications. SLMs often lack that, but yes, there are some SLMs which are good and can be used for model fine tuning, so that you might be able to use it for a specific purpose, like a specific domain or similar, right? Without having to worry about the whole world knowledge, right? That's not necessary. So if you can look at a specific use case, yes, that is a good option.
Okay. And the next question is, what are the 3 to 4 key factors to look into before one start for agentic AI app dev, which could be scalable and fault tolerant?
Yeah, so definitely, I think you would share the presentation later on, right, on YouTube or somewhere. But
Yes.
it has been covered in the slides. Maybe I was speaking too fast. But broadly speaking, one is definitely just like any cloud native application. You need to design it like that so that it has microservices. We are using the latest technologies, like using a Kubernetes cluster with horizontal scaling HPA, You are using things like load balancers, etc. Right? So which helps you to do, and auto scale settings are there, right? You're able to scale the pods based on the workload, right? Memory usage and CPU, etc. So that's the scaling part of it. And even if you're using Python, you can still design it as a microservice. So you can, for different, like in my case, I have created many microservices. So for example, for authentication, I have a microservice, right? So I built an application which authenticates and generates OTP, right? Or SSO, right? So it basically, all my applications will be using that. And, so this is a common service, right? So it's called, uh, auth service. So similarly, I have other common services which has encapsulated the common areas, right, of AI applications. So when I look at my different use cases and applications I have to build, I see what is common between them. For example, one thing I found common was uploading a document, vectorizing it, right, and embedding and storing into a database. So from the front end React, I would upload some documents or many documents, and it will do the entire workflow, right? The data pipeline, I would say. So that's like a common use case, right? So I have that in my common service as a microservice, right? And it is exposed to a REST endpoint, right? So it's not like you cannot use. I mean, you should also use the concepts that are well prevalent in a normal applications, right, on cloud scalability, and use like any of the clustering concepts, highly scalable frameworks, like wherever you can, right? For example, I use Redis. For example, it's a great open source, you know, product. So you should consider those, right? It's not like either or. Yeah.
Okay, and the next question we have is how to determine the cost or total cost for building such a system and how to optimize it.
Very, very good question. Um, so the way I would say is that there are many buckets of cost, right, of a building. So one is definitely your cloud cost, right? I mean, you know, and then you have other tools costs, right? I mean, you may have to subscribe or pay for few of the tools that you cannot find open source, right? And the third is, of course, the building cost, right? The human cost, or or building something, right? Uh, isn't it? So, and of course, all the services you are using, LLMs and whatever, right? So that is another cost, right? So the way that you might be able to optimize it is that, for example, in our case, we were able to get 1 year free subscription on Azure, right? That is unlimited use. So we can use any services at Azure, right? For the first 1 year, right? So we are using that, right? I mean, we got about 3 or 6 months from Google, but we so that's why our current deployment is on Azure, right? Although it is cloud agnostic, but we are running the infrastructure on Azure, right? Because it is free for us first year. So we don't have any cloud costs, right? Yes, there is a LLM cost. Again, the LLM cost also, you have to choose the model accordingly. There are so many models. If you look at Anthropic, they have this Claude 3.7, 3.5. There's many lower models also. Like HiQ is a good model. There's a model called HiQ in cloud, right? It is very cheap. It's 15 times cheaper than a Cloud 3.7. But for many use cases, it works extremely well, same as others, right? Little variations maybe with the answers, like in terms of size of the answer, right? The length of the outcome. But it is pretty good. So you might choose that, might work for you, right? It's not necessary you have to always use the latest and the greatest model, right? You have to experiment and see, right? And similarly, when it comes to document parsers, etc., some cases you'll find that they have a free tier which might work for you initially. Like Langfuse is a good example. So they're, I think they have a free model which I'm using now, right? And about 50K traces, right? I think per month or something, right? Which is not a small number, right? We have not crossed that, especially in B2B. It's difficult to cross that number very easily, right? Unless you have many customers. So, like that, you have to analyze it, and choose, right? And then people cost, my take on that is, in our case, we didn't hire much people, to be honest, right? Because that's actually the major cost for a software company, right? So my the way I have done it is I have actually done it myself, right? I have done everything myself, including DevOps, whatever is there, right? Front end, back end, whatever you see has been done by myself. I learned and they did it, and it works also, right? And customers use it. So again, that's my take on that. But yeah, we just hired somebody recently, one person on the front end, because we have more things to build. But it is a great thing if you can do things yourself. That's my take. So you can save a lot of money and you can actually build something that you want to build, right? Then and if you are really good at it, you can do it.
Right. And another question by Mohammed Shadab is, what should be the best practices and flow one should follow to feed data to the bot, and how to make sure its efficiency, performance, and output correctness?
Yeah. So any bot is picking data from some kind of vector store, usually, right? So it is more about the embedding of vectors or the data to the vector store and storing it efficiently. So in my slides, we discussed that, right? There are different techniques available with the vector store that you choose. Retrieval is a function of your embedding and filters, right? Primarily, and of course the type of deployment you have done, right? So, for example, you can have multi-tenant setup. Here, every tenant has the data separated. And when you're making a query on a tenant, let's say my tenant is a customer, like I have a B2B space. So let's say I have 100 customers. So I can have 100 tenants, right? Which is not too big. And when I run a query on a tenant, it will go to that specific shard, and the data is sharded, right, across multi-cluster, right? So it will figure out where to get the data from. So it's not doesn't have to do a full index search, right? And there are so many parameters to define in quadrant, for example, right? You can say, when it will actually go and search across the database. There are also parameters which defines how many. So what a vector database does, it sort of creates a graph of your data, right? Nodes are connected. The similar information is connected to each other, right? And those are called nodes, right? So what happens is when you send a query, it hits a particular nodes and keeps traversing, right? And finding out where are the closest similarities. So the graph construction depends on many factors. So one is the size of a embedding. You can define the distance between two nodes, right? And a configuration. So the closer the distances, the vectors are more dense, and it will actually take more space up, right? So you have to define these things, so then you can get good retrieval accuracy and speed. Refer to the presentation maybe once you have time.
Yes. So I think we are already short of time, but running out of time. But I guess we have another question. So, yes, how agentic AI gives a better answer, how it narrows its answers from a large pool of documents, source, etc.
Okay. So again, it goes back to there are probably 3, 4 reasons, right? One is the vector data extraction and storing. We've spoken about it, right? How you store the data, how well the vector database is, and the similarity search it is doing. So this is finding similarity, the word similarity, and it is based on embedding and the distances, right? Distances between the different tensors which are stored, right? And it is doing the similarity and nearest neighbor searches. So it finds the data, right? And the second part is the prompting part, right? How well the prompts are done. So depending on the prompt, right, your engine, the agentic system you have built, right, is actually going to execute, right? So your prompts are important because depending on what you want out of the agentic system, the query construction, etc. And so you give an input query, right? And then there's a prompt which is coming and there's a context. So these three things kind of gets together, and it goes and fetches data, right? So it fetches the data, and once you fetch the data, right, so that becomes the context of it along with that history, and then you have got the prompts, right? So this all helps the LLM decide what I should finally produce as an output, right? And then third is, of course, the orchestration of the agents, right? So that's where the land graph comes in, that you can orchestrate the agent. For example, one agent has fetched the data. You can have another set of agents, which is figuring out whether how truth or how factual it is. You can also score the results. So, for example, you can score the result. You have a question, you have the answer, right? So let's say I ask the weather, the agent is responding temperature, right? So there is a no factual similarity between it. It's not happen, but I'm just saying. So it's a very easy example I give, but let's take even in complex examples, you may ask a question, right, where you get an answer, right? And then you have another agent or a set of agents which will score the answers, right? And you find out how relevant or how relevant is the answer to the question. Other factors are like you may have very complex question that which could be subdivided into 3 or 4 questions, right? So you may have a question which is multi-line, right? So what happens is this agentic system can break up this question into multiple, right? It will break up the into multiple parts and do a parallel search. Once the results come, right, it will join the results and send it to the LLM for summarization. So as I said, LLMs are very good for summarization, right, and generation of final results. So that's the purpose of the LLM, and the agents are mainly to get the right answer, right context to the LLM.
Okay, so I guess that's all. We're done with the questions. And thank you so much for this incredible session, Atanu. All credit to you.
Thank
And
you.
to everyone here, thanks for joining us. I'm also sharing our Discord community link here on chat. I've shared it already. So y'all can join it and y'all can stay updated with the world of DevOps. And we've also shared a survey link. So after the call ends, you can fill the survey form and you can let us know what you thought about the session. So yeah, I guess we had a really informative session and thank you everyone for joining in. Thanks, Atanu. Have a good day, everybody.
Thank you very much, everybody, for joining and listening to us. Yeah, thank you.